point 1, comma 3 is shown in the xy plane. The quadrants are also shown. Square S not shown has one vertex at 1, comma 3 and an area of 25. So in other words, each side has a length of 5. One pair of the sides of the square have slope 3/4. Not counting the vertex 1, comma 3, square S has 3 other vertices. In which quadrants could any of the other vertices of square S fall? Notice that points on the x and y axes are not in any one quadrant. So indicate all such quadrants. So this is a hard out-of-the-box question. First of all, let's get rid of the text and let's look at the plane itself. So first of all, let's think about the slope of 3/4. A slope of 3/4 would be a run of 4 and a rise of 3. And of course, a run of 4, a rise of 3, that would be a length of 5. And so that could be one side of the square, or we could go in the other direction. We could go here. So these are two examples. So either one of those could be the top or the bottom of the square. Okay. Well, now we have to think about what would be perpendicular to that. So if one slope is 3/4, the perpendicular slope would be the opposite reciprocal, the negative sign reciprocal. So that would be negative 4/3. So negative 4/3, if we went down 4 over 3, we'd be here. Down 4 over 3, we'd be here. And then down 4 over 3, we'd be here. Whoops. Down 4 over 3. Sorry, right there. Okay, that's incorrect. And so we could have a square like that. That would be one possible square. We could have a square like that. So these are two squares, area 25 because each side has a length of 5, and it has one vertex at 1, comma 3. And so right away we see we can have vertices in quadrant 1 very clearly. We can also have a vertex here in quadrant 4. These two are on the axes, so we can't draw any conclusions about that. So these two squares we created by using the two original segments as tops of the squares. Well, now let's think about bottoms of the square. A slope of negative 4/3 means go to the left 3 and down 4, but it also means go to the right 3 and down 4, but it also means go to the left and up 4. And so it could be there, to the left 4, left 3, up 4, could be there, or to the left 3, up 4 could be there. And so now we could have points up here. So we get another point in the first quadrant. We get these points here in the second quadrant. And so any of these 4 squares could be the square. Any of these 4 squares follow all the rules. They have the proper slopes, they have the proper areas, and one vertex of the square is 1, comma 3. And so all of these are possible squares. And notice that we have vertices in quadrants 1, 2, and 4, but none in 3, because we have this strange side here that jumps from axis to axis. It has 2 endpoints on the axis, so it kind of jumps over quadrant 3 without landing in it. And so quadrant 3 is the only one that is not included. So when we go to the answers, we select quadrants 1, 2, and 4, but not quadrant 3, A, B, and D.